In this lesson, we are going to learn implicit differentiation. So we have done differentiation already, and what we have done is explicit differentiation. So what implicit? Explicit differentiation means y is isolated. So we have seen y equals f of x, and y is solved. Implicit function, it means that y is not isolated, so x and y is together. Then the procedures for solving implicit function is with differentiation both sides. It doesn't matter what you are having at each side, we are going to do the differentiation, but remember that y is a function of x. So whenever you see y, you do the differentiation, we are going to write as dy by dx. But in the equation, you may have more than one dy by dx. We are going to do the differentiation, then we are collecting the dy by dx as like terms and solve it. So first step, just do the dy by dx to both sides of your equation. Then x differentiation is same as before. We can apply the power rule for polynomials, quotient rule, chain rule, and also to sin x, exponential logarithmic function. Do the derivative as normal explicit function. If you see x, if you see y, you just write as dy by dx. So we are going to see how it works. So this one, we have x and y cubed. We treat it as a product rule. So we are going to do, we can separate it 2x by itself and y cubed by itself. So first term, we do it first. So we have u times v. Then u derivative 2x derivative give you 2. Then we copy the v here, y cubed. Then plus u, we don't change. Then we do the derivative to y cubed. When we do the y cubed, we do the power first. So we are going to have 3 to the front, then base, don't change, power 3 minus 1 give you 2. Then don't forget, the base is a function of x, so we have to do dy by dx here. So that is for the first term. Then we do the same thing for the second term. We are going to put 3x cubed together and y by itself. So 3x cubed will be another u times v. So minus bracket 3x cubed, we do the derivative, we have 9x squared. Then copy the v, then plus u 3x cubed times v is y, y derivative to x is dy by dx. Then to the right side is 1, 1 constant derivative to x is 0. So this is our step 1, dy by dx to both sides. This is step 1. Then step 2, we are going to isolate dy by dx. So all we call solve for dy by dx. So we are going to collect the dy by dx together. So we have dy by dx here, and we have dy by dx here. So we need to get rid of the bracket in order to collect the like terms. So we are going to have 2y cubed plus 2x times 3y squared give us 6xy squared. Then dy by dx minus negative apply to both terms. So we have minus 9x squared y minus 3x cubed dy by dx. equals 0. Then we put dy by dx together and move other terms to other side. So we have 6x y squared minus 3x cubed dy by dx. Then move the other two terms to other side. We have negative 2y cubed plus 9x squared y. In order to solve dy by dx, we want to move this bracket to other side. This is multiplication. The opposite operation is division. Then we are going to have the left side brackets cancel out. Then we have dy by dx equals negative 2y cubed plus 9x squared y over 6xy squared minus 3x cubed. Then this first question is done. So what we have done is we do the derivative dy by dx to both sides. Then after that, we isolate dy by dx, collect the like terms, dy by dx, common factor together. Then we move whatever at front of dy by dx to other side. Then we got the dy by dx solved. So that is example 1. Then we are going to see example 2, solve for dy by dx. So we do the same thing. So step 1, we are going to do the derivative dy by dx, not dy by dx, because it's just each side. Maybe not y, but we still want to just do the derivative to both sides. If you see the y, then we are going to do the dy by dx because y is a function of x. So the left side, we have base to the power, so we do the power first. So it will be 3, then the power minus 1 is 2. Then don't forget we need to do the derivative to the base. So we have 1 and the base is 2. So x derivative to x is 1 and y derivative to x is dy by dx. Then equals x cubed is just same as before, is 3x squared. And y cubed, we do the y, the cubed first, then do the y. So cubed is 3, then degree minus 1 is 3y squared. And don't forget the base is a function of x again, so we have dy by dx. Then we are going to expand the left side. We have 3x plus y squared. Then plus times 1 is itself, then 3x plus y bracket squared dy by dx equals 3 squared minus 3y squared dy by dx. Then we want to, step 2, we want to solve for y dy by dx. Then it means we are going to move dy by dx to one side, and maybe we just move the dy by dx to the left side, then the terms without dy by dx to other side. So we are going to have 3 bracket x plus y bracket squared, then dy by dx. Then we move the minus 3y squared to the left side. You will have plus 3y squared, then dy by dx. Then equals 3x squared. The other term is minus 3 bracket x plus y bracket squared. Then we combine the dy by dx, common factor, the front coefficient will be added together. So that equals the right side, 3x squared minus 3 bracket x plus y bracket squared. Then divided both sides by the coefficient at front of dy by dx, then you will have the answer for the dy by dx. Then we are going to have dy by dx you could simplify it. It will be 3x squared minus 3x squared minus 6xy minus 3y squared. So 3x squared cancel out. Numerator is negative 6xy minus 3y squared. And the denominator is add this together. So it's positive 3x squared plus 6xy plus 3y squared, then plus 3y squared, you will have 3x squared plus 6xy plus 6y squared. If you continue simplify further, 3 cancel out, you have negative 2xy minus y squared divided by x squared minus plus 2xy plus 2y squared. That is done. So that is a dy by dx for this question. Then we can continue to example 3. Example 3 asks you to determine the equation of the tangent to the curve x cubed plus y cubed equals 9. And you will see this is not y equals something. So we call this is an implicit function. At point, this is x value, this is y value, is given for you already. So using the implicit differentiation. So you could solve y, then you will get explicit. So sometimes you are able to change the implicit function to explicit function, but this question asks you to use implicit differentiation. It means you need to use a dy by dx to both sides to solve it. And whenever you see equation of the tangent, we know we are looking for the equation of the line. So y equals mx plus b, or the point slope form y minus y0 equals m times x minus x0. So x0, y0 is a point on the graph. Either way, it's correct. So we are going to do the, no matter what, we need to find the slope, m, slope first. Slope is a derivative, dy by dx. So step 1, we want to do dy by dx to both sides. So you will have x cubed is just 3x squared. And y cubed, like the chain rule, we do the power first, so 3y squared, then do the base. Base, y is a function of x, so dy by dx. Then equals d0 by dx, constant, derivative is 0. So this one we solve for dy by dx. This is our slope. By moving the 3x squared to other side is negative 3x squared. Then move the 3y squared to other side is multiplication. Opposite operation is division. Then the left side you will have dy by dx equals negative 3 divided by 3 is negative, so x squared over y squared. Then we sub the xy value is a point on the graph into this equation 1 to find the slope at that point. We're going to have dy by dx, that is our slope, equals negative x is 2 squared, y is 1 squared, so we have negative 4 over 1 is negative 4. Then after that, we are going to step 4 to find the equation y equals mx plus b. In this equation, we have the m already. We want to find the b. And in this equation, we have 4 letters, so we have to sub in 3 of the letters in order to find the last one. So we have m equals negative 4. The xy is the point on the line is 2 and 1. Into this equation, we have 1 equals negative 4 times x is 2, then plus b. So we move the negative 4 times 2 is 8, to other side is plus 8. So we have b equals 9. Then our final answer is y equals negative x, mx is negative 4x, b is 9. So this is the equation of the tangent line that passes through the point 2, 1. So this is for this lesson, and what we have done in this lesson is we have 2 steps. The first one is dx dy, d over dx to both sides if it's not y isolated. Then we just treat y as a g at x and do the chain rule. So and isolate dy by dx. Then we have the dy by dx. Thanks for watching.